Listening Comprehension for Scientific English by Jonathan Upjohn. Unit 2, Frequency. Listening with your eyes. Part 1, Keywords.
A curve. To design. A device. To display. Evenly. A feature. Flat. Hardly. To link. Minute. A pattern. A peak. To plot. Recurrent. A scale. Seldom. A shape. A stress. Tiny.
New words.
The deaf and dumb. A native speaker. To reveal. The tongue. Naught.
Do you recognize these homographs?
Therapy. Milliseconds. Staccato.
Part 2, Exercises. Now, listen to the text and answer the questions. Stop the recording when necessary.
Some people are now saying that looking at a computer screen can help you improve your accent. What we're going to hear about today is a device that was originally designed to help speech therapy with the deaf and dumb. However, the IBM VisiPitch is being adopted little by language teachers. The system consists of an oscilloscope linked to a computer, and it can be used to help teaching intonation and stress. John Skelton has been trying it out.
Well, the teacher speaks a model phrase into a microphone, the sound waves are transformed into electric pulses and then displayed on the computer screen. Then it's the learner's turn to try to repeat the phrase as accurately as he can. The curve of his phrase is displayed under the teacher's model on the monitor. This means that the student can make a visual comparison of the outlines of the two speech patterns on the monitor. If you look at the drawing in Figure 1, the curve represents a stress pattern of a French speaker who knows very little English, saying,
Elizabeth is going to the market.
The intensity, measured in decibels, is indicated on the left-hand vertical axis on a 0 to 5 scale, while time is recorded on the horizontal axis in milliseconds. Now, what are the characteristics of this curve? As you can see, it consists of a series of fairly regular peaks, ranging between 3 and 5, followed by falls to 0 level. Each peak occurs more or less at the beginning of a syllable. This is a typical pattern for a French beginner trying to speak English. He is simply transposing the French language system, and that's why it sounds wrong. Compare
Elizabeth is going to the market.
And Elizabeth's going to the market. Did you hear the difference? To help you see it more clearly, I would like you to plot the curve of the English stress pattern onto Figure 2. The shape of the curve is very different. It consists of two very heavy stresses, one on the first syllable of Elizabeth, and the second on the first syllable of going, with only minor fluctuations in between. On the first syllable, at 150 milliseconds, there's a peak to 3, which immediately falls to 0 at 200 milliseconds. This is followed by a more gradual rise to 2 at 280 milliseconds, and an immediate fall. The signal remains at 0 until 390 milliseconds, where there's a very small rise to 0.5. The signal remains completely flat until 1300, with the exception of a minute fluctuation at 810. The shape of going is a symmetrical series of peaks, first to 3, and then a very small fall, again a rise to 5, and an immediate fall to 2.8 and a rise to 3, and then a fall to 0 at 1500 milliseconds. From then on, the signal remains flat until 1790, where there's a reading of 0.4. For the final word, market, the curve attains a peak of 2 and then drops back to 0 over a period lasting 200 milliseconds, and then nothing more except two tiny 0.3 fluctuations at 2150 and 2300. As you can see, the second curve is totally different from the first. There's a strong rhythmic beat. Da-di-di-da, di-da-di-di. That is to say, there's a recurrent, evenly distributed stress falling on lexical words, words which have meaning. On the other hand, grammatical words have almost no stress. Languages that tend to fall into this category, besides English, another example is German, are called stress-timed languages. In contrast to this, in French, there's a general tendency for each syllable to be stressed, which makes it sound rather staccato or like a machine gun. Such languages, including Spanish and Korean, are called syllable-timed languages. Now, the problem for learners is that they filter what they hear through their own language system. That's why it's difficult for them to learn the sounds of a foreign language. They can hardly ever hear them in the first place. So, by giving learners a visual display of the sound on an oscilloscope, they can see what they should be hearing and consequently learn to speak better.